So let's graph the second graph of trigonometric function, which is y is equal to cosine of x. And in our previous videos, we graphed this first graph of trigonometric function, which is y is equal to sine x graph. And using the information that we used to graph it, we can also be able to graph the y is equal to cosine x graph. So just like we did it in our previous videos, in this video where we're going to graph the y is cosine x, I will do it a little bit faster because it's kind of a review what we did in our previous videos. So firstly, let's start off by thinking what is the unit circle, and I will review it quickly for the briefly. To graph the y is equal to cosine x graph on the coordinate plane. So as we have learned in a lot of previous videos, this is an unit circle with the radius of 1. And I won't explain a lot of detail because this is just a review for the unit circle. So there's the angle of rotation 0 degrees, pi over 2 radians, pi radian, 3 pi over 2 radian, and 2 pi radian. And I'm going to explain a little bit faster right now, and if you're not familiar with it, you need to go back to my previous video about y is equal to sine x graph. So from this one, they have their own coordinate, which is foreign with the x and the y value. So firstly, when it's 0 or 2 pi radian, then it has the 1, 0, as it gets to pi over 2 radian, 0, 1, negative 1, 0, and 0, negative 1. And this is a unit circle. So if you get a random point on a circumference of the circle or the unit circle, let's say there is a something like this, and let's say the angle that rotated in the from the straight line, if we call it as the random angle measurement data, then we can figure out what is the coordinate for this point on the circumference of the unit circle. And again, the way to do it, just like we did in the previous videos, we need to make a straight line like a right triangle, and we always need to notate the right angle to show that it's a right triangle. Then, obviously, from 0 all the way to this point here, that will be the x value for the special angle rotations data. And this value will be the y value. And using this information is where the hypotenuse of our right triangle is equal to 1, because that is the radius or half of the diameter of the unit circle. Then from here we could define the sine, cosine, and tangent of this main angle. So the first thing that we're going to talk about is the sine of the main angle theta. And again, just like we did in our previous videos, in my own technique to memorize how to find the y in the sine data, cosine data, and tangent data. We use the signature letter. For sine data, we always draw off the hypotenuse, and we always draw the s along with the side that is opposite with our main angle. And if you're not familiar with this concept, you need to go back to my previous videos about how to memorize the right triangle ratios. So whatever the value where we start off will be the value in the denominator, and whatever the value where we start off will be the value in the numerator. So we start off the value hypotenuse as 1, so denominator will be 1, and we finished at the opposite value or opposite side of our main angle as y. And if we simplified, something divided by 1 will give us the itself. And we get a conclusion where sine theta is equal to y. That means inside the unit circle, the sine theta will get replaced with the y coordinate or the y value. The second thing to remember is what is the cosine of the main angle theta. And again, just like the sine, we use its initial line as c that always draws off the hypotenuse along with the main angle. It will go all the way down to the adjacent side of our main angle. So the value, whatever the value we start off, will be the value in the denominator as 1 in this case, which is hypotenuse, or the radius of our unit circle. And the value where we finish off, and that is the adjacent side of our main angle, which is x value. So x divided by 1 will give us the value itself as the x value. That means inside the unit circle, just like we talked about in the previous videos, the cosine data will be the x-coordinate or the x value inside the unit circle. So last value or last three values that we need to remember is the tangent data, which is the ratio between sine and a cosine. So for tangent data, we use t that always start off the adjacent side of our main angle and finish at the opposite side of our main angle. So the value where we start off, which is the value that is adjacent with our main angle, x in the denominator, and the y value in the numerator, and at y over x is the slope of, for example, like a linear function, but in this case, the tangent data inside the unit circle is going to be the slope. Another way to say how steep the trigonometric function is. And these are the basic three things that we defined inside the unit circle. And using these values, we could be able to define or graph the y as sine x, cosine x, and tangent x graph. So after we rearrange these values, now let's think about the next thing to review inside the right triangle ratios on the unit circle. We rearranged the positions of the things that we already learned, and now let's think about the general angles that we think about inside the right triangle. So there are three types of special angles: pi over 6 radian, pi over 4 radians, and pi over 3 radians, which are 60 degrees, 45 degrees, and the 60 degrees. So 30 degrees, 45 degrees, and 60 degrees. So just like we did in our previous videos, let's say the angle rotations of the angle measurement is pi over 6 radian, which is 30 degrees. And to think about the coordinate that is being formed by the angle rotations, we always need to make a right triangle. So let's say this is the right angle that shows that this is a right triangle. And let's say there is a point here, and just like we learned in our previous videos about y is sine x graph, or how to memorize the right triangle ratios, the point or the coordinate will be square root of 3 over 2 comma 1 over 2. And now the square root of 3 over 2 and 1 over 2 is the x value and the y value. But according to what we learned here, where the sine data is the y value, cosine theta is the x value inside the unit circle. That means the square root of 3 over 2 will be the cosine, which can be notated as the cosine of the main angle measurement pi over 6 radian. And 1 over 2 can be notated as the sine of the main angle pi over 6 radians. And this is how we describe an angle rotations in terms of coordinate. So we will be able to use the sine data is y and cosine data is the x value. So this will happen when the angle rotation is pi over 6 radian. Now let's think about the next one, where the main angle or the special angle is pi over 4 radians. So let's say there is an angle rotations from the origin, which is 0, 0, from all the way to here, and let's say that, or let's assume that the main angle rotation is pi over 4 radian, which is 45 degrees. Then the angle measurements, pi over 4 radian, it creates one coordinate for this. And to think about it, we always need to make a right triangle by making a straight line all the way to the positive x-axis in this case. So with the right angle, the right triangle will be formed. And just like we did in our previous videos, we'll be able to describe what is this coordinate right here. And using the right triangle ratios of 45 degrees main angle, we can describe the coordinate. It will be square root of 2 over 2, comma, square root of 2 over 2. And that means the ratios between the x and the y value will be exactly equivalent. And the square root of 2 over 2 in the x position will be the cosine of the main angle pi over 4 radian, which is 45 degrees. And square root of 2 over 2 in the y position is the sine of the main angle pi over 4 radian. And this is how we describe the cosine and the sine value, another way to say coordinate when the angle rotated pi over 4 radians. Now let's think about the last special angle rotations, pi over 3 radian, which is 60 degrees. So the blue line, let's say that the angle rotated pi over 3 radian, and pi over 3 radian states for 60 degrees in terms of degree mode. And to think about the coordinate that is being formed, because of the angle rotations pi over 3 radians, we need to make or create a right triangle. Then we will be able to express this point on the unit circle using the right triangle ratios of the special angles. Then, according to what we have learned in our previous videos, if we express this angle rotations, then the x coordinate will be 1 over 2, and the y value will be square root of 3 over 2, and that will happen when the main angle is pi over 3 radians. And 1 over 2 is the cosine of the main angle, which is pi over 3 radians, 60 degrees, and square root of 3 over 2 will be the sine of the main angle, pi over 3 radian. And this is how we express the cosine of the main angle, pi over 3 radians, sine of the main angle, pi over 3 radians. And this was the explanation of the sine, cosine, and tangent of the special angles, pi over 6 radian, pi over 4 radian, as well as pi over 3 radians. And using the informations of the unit circle, and also the informations or the knowledge that we used to graph the previous videos graph y is sine x, we'll be able to graph the y is equal to cosine x graph. So after arranging these values over this picture, let's graph the y is equal to cosine x graph. Now we are going to graph the y is equal to cosine x graph, and we're going to apply the exactly same concept we applied to y is sine x graph. And inside y sine x, what was the x value that goes from the negative to the positive infinity? Well, there were the angle rotations. So the angle rotation means from the 0, it will go either the positive infinity or the negative infinity directions. And that is what the angle is. And for the x value from the negative to the positive infinity, that will be the y is equal to cosine x's graph's x value. That means just like the y sine x graph, the x value, which is the angle rotations on the unit circle, has no limitations. That means the domain is all real numbers. However, the y is equal to cosine x graph, y value has limitations. And we will figure it out just like the y sine x graph after thinking of the first period from 0 to 2 pi radians on the coordinate plane. Now this is the basic graph of y's cosine x from the 0 to the 2 pi radian, which is the 1 period, just like y sine x graph. So firstly, what is the x value from the negative to the positive infinity, just like I mentioned? That is the angle rotations that can go positive or negative infinity direction in the angle rotations. And for the y value, which has the limitations in it, that will be the following: y is equal to cosine, the cosine value, which is an x value inside the unit circle, such as cosine of pi over 6 radian, cosine of pi over 4 radian, and cosine of pi over 3 radian. And just like this, let's compare it with this y is equal to cosine x graph with the unit circle detail. So firstly, when the angle rotation is 0, then the following cosine x graph is positive 1. And the reason is because when the angle rotated 0 degrees, then the following cosine value, that is the x value inside the unit circle, that will be the positive 1. And positive 1 will be the cosine of the main angle 0 degrees. That's why it starts off the positive 1. And as the angle rotates, as the angle gets bigger, and finally reach pi over 2 radian, and pi over 2 radian is 90 degrees in terms of the degree mode. Then, when it is pi over 2 radians, then the following coordinate will be 0, positive 1. And what is the x value? The x value is 0. That will be the cosine of the main angle, pi over 2 radian inside the unit circle. So, when it is pi over 2 radian, it will be equal to 0. And as the angle rotates even more and gets or increases, then as it reaches the pi radian, which is 180 degrees, when it is 180 degrees right over here, then the following cosine value, which is the x value, the cosine of the main angle, pi radian, is equal to -1. So when it is pi radian, the cosine value on the y is cosine x, which is the y value, will have its minimum value as the -1. And as the angle rotates and reaches 270 degrees, which is 3 pi over 2 radian, then the x value will be equal to 1. When the angle rotates 3 pi over 2 radian, then the angle cosine of the main angle 3 pi over 2 radian will be equal to 0. And lastly, as the angle finish as 2 pi radian and finishes period, then as it gets to 2 pi radian again, the cosine of 0, or a cosine of 2 pi radian, is equal to positive 1, and the positive 1 will also become a maximum value for y is cosine x graph. So from the 0 all the way to 2 pi radian, this is the first graph with the period of 2 pi, just like y sine x graph, from the 0 to 2 pi radian. So if a quick review, from the positive 1 when the angle is 0, as the angle increases, the y value, which is the following cosine value, inside the unit circle decreases. And as the angle increases even more, when it gets to the pi radian, which is 180 degrees, then the graph decreases even more and will have its minimum value as -1 when the x, or angle rotation on the unit circle, is pi radian. And the angle, as the angle increases after it hit its minimum value, then it will keep increasing, and as it gets to the 3 pi over 2 radian, which is 270 degrees, then it will get back to the 0. And as the angle rotates and finishes cycle at 2 pi radian, then the following y value on the cosine x graph, or the cosine value as well as the x value on the unit circle, would get back to the positive 1 as its maximum value when it finishes its one cycle, or another way to say, period. So this is the basic structure of y's cosine x from 0 to 2 pi radian, and now let's think about its properties. Rearrange the y is equal to cosine x graph. And the first property we're going to talk about inside the y is cosine x graph is what is the domain. And when we're thinking of the domain, it is same thing with saying what are the all possible x, or the input values we can input to the cosine x graph. And for a domain, inside the trig values, just like we mentioned, it is the angular rotations on the unit circle that can rotate the positive or the negative direction, infinity directions. So that means from the negative infinity to the positive infinity inside the y's cosine x, the domain will be all real numbers. And the all real numbers means any kinds of values from the negative to the positive infinity. That'll be the x value that satisfies the y is cosine x graph's x value. Now let's think about the range. And the range means if the domain is all set of numbers where we can input the x value, then the range will be the all possible y value we can input to the y is equal to cosine x graph. For a domain, there was all real numbers, which means there was no limitation in it. However, inside the range there is. We can figure out that inside the y's cosine x, from the 0 to the 2 pi radian, which is first period, it has its maximum value as positive 1 when it's 0, and also when it is 2 pi radian. And it has its minimum value as negative 1 for the first period, from 0 to 2 pi radian in the pi radians. So just like this, the y value won't go over the 1 and it won't go under the negative 1. That means the y value is stuck between the negative 1 and the positive 1. So if the y value won't go under the negative 1 and the y value won't go over the positive 1, where the domain has the value of all real numbers, then from here we can drag out one informations. And that will be the third informations or properties of y's cosine x. The maximum value, where the y value won't go over on the graph, will be equal to the positive 1. Secondly, the minimum point on the graph, which is the lowest point on the y's cosine x graph, will be equal to negative 1, where the y value will never go under him. So we can figure out that the maximum will be equal to positive 1 on the y's cosine x graph, and the minimum or the lowest point is going to be negative 1. And the last thing that I'm going to talk about inside the properties of y's cosine x is the period. And what is the definition for the period? Period means after a certain area, or after a certain form is formed for that graph, they'll be continued to the positive and negative infinity directions. And for the cosine graphs, just like the sine graph, the period is 2 pi radian, where the form between the 0 and 2 pi radian, which means on the unit circle 0 to 360 degrees, this form will keep continued to the positive and negative directions. So the form where the y value gets positive 1 and the y value gets to 0, negative 1 as its minimum value, 0 as well as the positive 1, these values from 0 to 2 pi radian will keep continued. So the period, which shows that after a certain form is formed, they'll be continued to the positive and negative directions, it will be equal to 2 pi radians. So that means it can either go negative or the positive directions. So I'll draw the case where the graph from a 2 pi radian after one period is formed. I will draw the second period or second form for the cosine x graph that starts from 2 pi radian and finish at 4 pi radian, which is 2 pi radian addition from the 2 pi. So if you graph one more period of y is equal to cosine x graph after shrinking this value or this graph from 0 to 2 pi radian, it will look like this. So the first period that we looked at, which is from the 0 to the 2 pi radian, so we know that the pattern is the y value starts at 1, gets to the 0, and gets to negative 1 as its minimum value, and get back to 0, and then goes to the positive 1 as its maximum value as it finishes period when the x is 2 pi radian. And I graphed one more period. That means from 2 pi, since we know that the period is 2 pi radian, another graph will be formed in the 4 pi radian. So with the same pattern where it starts from 1, and then it gets to the 0, it gets to negative 1, it gets to 0, and it gets to the positive 1, this will be the first period of the second period of y's cosine x. And I will increase or I will make the size of the writings bigger. So just like this, from the 0 to the 4 pi radian, where I graphed the 2 period of y's cosine x. But we need to remember that this is just one of the whole graph of y's cosine x that will range to the positive and negative infinity directions. But only thing that we need to remember is the formula of y's cosine x that starts from the positive one, whereas it gets to the pi radian, it gets to 0, and where it gets to the pi radian as the x angular rotations on the unit circle, then the following y value is -1, and as it gets to 3 pi radian, it gets to 0 again, and it goes to 2 pi radian. And the only thing we need to remember is this form, from 0 to 2 pi radian, which is the first period for y's cosine x graph. So this was the basic properties of y is equal to cosine x graph. And in the next video, where I'm going to explain more in detail about y is equal to cosine x graph, in order to graph the rest of the trigonometric function properties, or the graph with such as y's tangent x graph, to compare this graph with y's sine x and y's tangent x, and more importantly, we need to graph the transformations or translations of the trigonometric functions. So let's review briefly about what we have done to graph the y is equal to cosine x graph. So first thing we need to remember is inside the y's cosine x graph, just like y's sine x graph, this x value is the angular rotations on the unit circle that can go either positive or negative infinity directions. So that means for a domain, which is the x value, inside the y sine x graph, it is going to be all real numbers. And for the range, which is the y value, and the y value on the unit circle is the cosine of the following main angle. And the range is between the -1 and the +1. That means the range is not all real numbers. So between this +1 as its maximum value and between this -1 as its minimum value, we can drag out one information. Maximum value inside y's cosine x is +1, and the minimum value for the cosine x graph is -1. And a lot of people might get confused with this concept. Let's say the x value here on the y is equal to cosine x graph. We already know that the x graph on the y's cosine x graph is the angular rotations. The angular rotations that rotates around the unit circle. However, inside the unit circle, the x coordinate, the x value, is the cosine of the following angle. That means the x value inside the unit circle and the x value in the graph of y's cosine x, or a graph of any trigonometric functions, those are completely different. The x value inside the unit circle is the angular rotations, and is the cosine value. And the x value inside the y's cosine x graph is the angular rotations on the unit circle. So we should not be confused with those ideas. So this was the thing that we had to remember, and most importantly, the y is equal to cosine x graph, including all trigonometric functions, they are the periodic functions that contains a period. That means the period that is a certain form, after a certain form is formed, that form will be continued to the positive and the negative infinity directions, and the form will be 2 pi radian. That means from the 0 to the 2 pi radian, where the y value gets from 1, 0, -1, 0, and +1 as the maximum value again, that will be the period for 2 pi radian. And this was the basic properties of y is equal to cosine x graph.